Hello, everyone. Welcome to another episode of TAQELAH webinar. We hope you and all your loved ones are staying safe and sane during these uncertain times. Today, we have Puneet, and Puneet will share his experience on catching bugs in backend service without writing test. Seems very interesting topic, right? About few words about the speaker. Puneet Khanduri is one of the founders at SN126, where he has built Isotope. In the past, he led the ML service group at Twitter. He also briefly served as the engineering lead for Twitter India while leading a few strategic projects from Twitter's Bangalore office. Puneet has also worked as a researcher at MIT and Sun Labs, where he designed networking protocols and microprocessor architecture. So we are so happy to have Puneet on the stage. Hello, Puneet. The stage is all yours.
Thank you so much, Yash. I really appreciate it. Thank you for the generous introduction. I guess one interesting tidbit that I might add about myself is some open source work that I did while I was at Twitter, Tiffy. This is a tool that has received a lot of traction in the industry when we open sourced it. So companies like Airbnb, Mixpanel, most recently Robinhood, and companies in China like Baidu and ByteDance have all been using it, and it's been growing in popularity. And then, what led to the beginning of Isotope was some fundamental limitations there. So I won't, this talk isn't about Diffie, but I encourage you guys to go take a look at it. What this talk is about fundamental concepts that drive products like Diffie and Isotope, and how we can stretch our imagination in terms of using our production traffic to create test scenarios without actually writing tests. So my co-founder Prashant Khanduri isn't here with us today, so he doesn't get an introduction. So we're just going to skip over this. But let's briefly talk about the problem that we're trying to solve. Right. So as quality engineers, we're always trying to make sure that the next release doesn't break production, and this is the worry that keeps us up at night. And we try our best. We make a lot of efforts and investments to make sure that this never happens, right? But eventually, we run into this trade-off between quality and time investment, right? Like with a limited amount of investment that you can make, you're forced to make some hard choices. To quantify, the kind of dilemma that we have, when we work with backend microservices, we measure things like cyclomatic complexity in the code base and things like that. So typically for most of our customers, we see that for a request path, like when you stand up a server and you send it a request and the response comes back, there's of the order of 15,000 to 25,000 code paths that can be exercised by a variety of requests. So if you want to exercise all possible code paths, that's the number of tests you'd have to write. Now, nobody wants to write this many tests. It's very, the upfront cost of writing a test for a piece of code is roughly 2.5 times the cost of writing the code itself. And no company in its serious mind can afford to make that kind of investment. Even if you end up making a significant investment in writing a large test suite, you run into the cost of maintaining that test suite, right? Because eventually, as your business evolves, your product requirements will evolve, and when your product requirements evolve, the product specification changes, and so then the test starts failing. So the feature, the way the code is now implemented is correct, but the test is obsolete, so the test is failing, and so now you need to go in and update the test, right? So the cost of maintaining these tests is also something that requires a lot of human effort, right? So with a limited amount of energy that we have as quality engineers, what do? Right? We have to make this compromise, this trade-off, right? That we realize that in production there's going to be thousands of scenarios that are going to be exercised, but we don't have the energy to cover every single one of those scenarios during our testing. So, what we do is we typically cover a handful of critical scenarios, right? We basically say that I have this sort of critical flow of, adding an item to my cart and then checking out, or, executing a particular transaction in a trade. And so those key scenarios are things that we will test, but we will not go through the pain of, enumerating every single corner case, every single possible flow through the product, and then making sure that all of those are working right. Meanwhile, that is exactly what happens in production, right? Like the moment you ship a product out into production, all the code paths light up, right? Like everything that was dark so far is now glowing. So the ideal scenario that we always desire here is that what if we could test all the scenarios that were going to be exercised in production during our testing, right? And what if we could learn from production and bring all of those scenarios back into our test environment so that we don't have to enumerate them and write them ourselves, because we know that when a product gets shipped out in production, our users are going to basically use all possible flows through it and all the ones that matter anyway. And so if we are able to capture all of those scenarios from the production environment and bring them back somehow to our test environment, then that gives us a lot more coverage than what we can hope to achieve by just enumerating things on our own. And that's basically the fundamental thesis behind a product like Isotope, right? So this concept is also referred to by some folks as shadow testing. Back when we were doing it at Twitter, we used to call it mirroring. And then after we open sourced it, it started getting popular. And I think Google most recently blogged about us and then called it shadow testing there. So the term shadow testing is something that's getting a little bit of stickiness now. But the idea is pretty simple, right? That we observe the behavior of a particular system in production to learn what its correct behavior is, to create some baseline expectations around when this kind of an input comes in, then this kind of an output is expected, and these kinds of downstream side effects are expected. We can then use this knowledge that we've learned from the production environment to create offline simulations for code that has never been deployed yet, right? And these offline simulations, should be extremely portable. You should be able to run these offline simulations locally on your laptop without having to, deploy 5 databases and 20 other services that your particular service may be calling out to. And then finally, an interesting problem emerges when you do this, because normally we operate in the realm of like tens or hundreds of tests. And when you're operating in the realm of tens or hundreds of tests and something breaks, then you have to look at, a handful of tests that are broken. And then, you can afford to go through every single one of them manually to figure out, what's breaking and then go fix it. The problem is then that when you're dealing with thousands of tests, if something goes wrong, then hundreds of tests start breaking, right? And if hundreds of tests start breaking simultaneously, then it becomes humanly impossible to go through every single one of those tests manually. So you need some sort of, intelligent, meaningful aggregation over your tests, so that the feedback is more consumable to you as a quality engineer or as a developer, right? And we'll talk about how we solve all of these problems. So how does it work, right? So the idea is that in order to learn the behavior, the correct behavior from your production environment, we provide the Isotope SDK, right, which is used to instrument your code. And then, that SDK is observing all the incoming traffic in terms of the requests and the responses that are going back. But in addition to doing that, it is also observing all the downstream interactions that your service may be having. So let's say, this particular service A version 1.8.0 that is deployed to production is talking to a MongoDB instance, it's talking to a MySQL instance, and it's talking to a service B over, it could be any protocol. It could be gRPC, it could be Thrift, it could be HTTP JSON, it could be any one of those things. So regardless of what the protocol is, right, like we basically observe all of those interactions, and then we use that knowledge to create offline simulations, right? So now that we've observed, a certain behavior here, and that behavior has been, sanitized and sent, to the Isotope backend, then the same instrumentation that you have in your code when you, let's say, make any changes, that instrumentation now changes its behavior and starts running in test mode, right? So when you've got version 2.0.0, the behavior that was observed in production is being replayed here. And then when this service A instance, the one that's isolated running locally on your laptop or in your CI system, tries to make a call to MongoDB or MySQL or service B, we are able to automatically mock the behavior of all of these dependencies without you having to write any kind of stubbing code, right? And the reason why we're able to do that is because we already know what the behavior of these services is expected to be based on what we learned in production, right? So that's where it's important to not just learn the ingress part of the behavior, but also the egress, the downstream dependencies part of the behavior, right? So once we've done this simulation, right now, that behavior goes back to the backend, and the isotope backend then does sort of a comprehensive comparison between the behavior of the service A version that was in production versus the service A version that was the test candidate, right? So you basically simulated a production-like environment on your test candidate without actually being in production. Now, one thing to note about shadow testing is that a lot of people will use live production traffic for shadow testing, and that sounds great, and it's a great place to start. But it has a very important limitation to consider, right? Which is that some code paths are very rarely exercised, right? Like some request paths are going to be exercised once every few hours. Right? 90% of your traffic will exercise maybe 10% of your code, but then the long tail 90% of your code will be exercised by the 10% of the traffic that happens very rarely. So what we do with Isotope is that when we are looking at the production environment, we're also performing real-time compression on the samples that are being observed by slicing and dicing those samples in terms of what kind of data patterns do they have. And based on the data patterns of the samples, right, what we do is we are essentially able to compress this huge millions of samples worth of data set into a few thousand, right? And that allows us to run simulations that are running in the order of a couple of minutes, right? And this is a very important step, because without this, you're left baking the artifact against production traffic for hours versus being able to run this in a couple of minutes. Then you can imagine running it locally on your laptop. You can even imagine being a part of your standard CI CD step, right? So that's the overview of how that whole sampling piece works, and how the comparison happens in the backend. At the end of this entire exercise, what happens is that you get a report that condenses all of these the differences in behaviors that have been observed across the expected behavior in production versus the observed behavior during the simulation. And you can go look at that report on the Isotope backend. So now I'm going to show you what one of these reports looks like. So let me go back here. Right. So what we did so far was, in order to run this entire simulation and test, right, we didn't actually deploy any additional piece of infrastructure. All you did was you added a library that we gave you to your code, and that's it, right? So that library is then communicating with the Isotope backend, and then I'm about to log into the Isotope backend with my account now. So let me do that. So I'm logged in now, and you can see all the services that we own at SN126, right? And of all of these services, I can go look at our geo service, for example. So if I click on the geo service, I can see all the different people who've been running simulations. Like anyone who's doing any kind of quality engineering work on this service will probably end up running a simulation. So there's Prashant, there is Puneet, myself, and there's our CI system. And I'm more interested in my simulations than Prashant's simulation, so I can look at that. And then I can see all the previous ones seem to have passed because they're all green, except for the last one, which is red, right? So let me click on this to see what it looks like. So now I'm looking at all the endpoints that exist inside our GeoService, and what went wrong in the simulation is this endpoint that's red. So let me click on the red here. So when I click on the red here, I can see that my request has a body, which has something called hub IDs inside it. And these hub IDs are business concepts that are internal to my business logic. Right? Association type is another concept that is internal to my business logic, my code's business logic. Right? But I don't need to teach Isotope anything about my business logic or my code. By virtue of the way the instrumentation works, it's automatically able to pick up my API schema without me having to provide any kind of documentation. And by the way, this also gives you sort of an interesting way to think about documentation, right? Because this basically is live documentation without you having to do any kind of maintenance on the documentation, having to update Swagger files or anything like that. So when I look at the body here, the response body, I have a latitude and a longitude, right? And that's where things are red. So let me just turn this filter on that only shows differences so that I can concentrate and focus. So I can see that the only thing that's broken is this get endpoint, and it has a response body with a latitude and longitude that seems to be broken. So when I look at examples of this latitude breaking, I can see that what I was expecting was something like 29.238478, which is a floating point, versus in the simulation, what I actually got was 29. So this floating point got rounded down to an integer. And I can see that the same thing happened with all the other examples of this bug. Right? All the floats got rounded down to an integer. And if I go take a look at the longitude, the same thing is happening. Right? The floating point values of these longitudes got rounded down to integers. Now, unless you've explicitly written a test for this, right, you won't catch this bug. And let's assume for a moment that you didn't write a test to catch this. Right? What would have happened? This change would have gone out into production. None of your alerts would start firing because this is just some very minimal change in the data. And what would happen eventually is that the operations team, the logistics team, would come back complaining to you that the GPS coordinates that the GeoService is giving are garbage. Right? The delivery has been completely disrupted for your business on the ground, because people just don't know where to go and make these deliveries. GPS coordinates are all messed up. So this is a big problem, right? And what we've done here is that without writing any tests, we've been able to catch this problem, as early as the first time we run this test. And that could be like locally on the developer's laptop, or it could be in the CI process. It could be done by the QA team. And so that allows us to catch all these sort of corner case scenarios that we haven't thought of, right? To make this even more actionable, what we can do is we can click on one of these examples, and then we can see the full story of what happened, right? So in here, when I'm looking at this one example, it's telling me that I had an input which had a body, which had an association type zip category, and then hub IDs, these three values. And then in the output, it's telling me that it had a body and it had a latitude and longitude that were these floating point values. Similarly, during the simulation, it's telling me that it had the same input, obviously, but then the output was the part that went different, and these latitude and longitude values got rounded down. Right? This is giving me the full story of what actually happened in this particular example. And what it's also giving me here is a unique transaction ID that we assign to every sample that we collect, which can be used to instruct the SDK that, hey, I want to run this one sample in isolation. And then, when I'm running that one sample in isolation locally on my laptop, I can, attach a debugger to my code and step through my code line by line as this production scenario runs locally on my machine to see where things broke. right? So like reproducibility of weird behavior that has been observed now becomes very, very easy because you have these concrete examples that can be shared and that can be, replayed as many times as you want, and they can be replayed in isolation or in groups. So you can have like thousands of these, which is what isotope normally does. But if you wanted to just attach a debugger and sort of like trace through your code manually, you could also do that. So, that's, a very sort of quick overview of, all the, the core value that, that Isotope offers. In terms of integration, right, the way we've approached this is that we have a proxy that you can deploy. So this would be like a network proxy that sits in front of your service to observe the behavior of your service. We support Node.js and Java. So we provide you with SDKs of these languages so that you can add this instrumentation to your code. And then we're always taking like requests for new language support. The idea for this talk for me primarily is to inspire you guys to think about like using your production traffic to create these simulations so that you don't have to write manual tests yourself, right? This is the way we ended up doing it, and we're limited by our creativity. But I would love to hear, from folks in the audience also, like how they would want to build a system like this that might be different, and if there are any ideas on how we could make our product more valuable to you guys also. So with that, I'd like to open the floor up for questions. Um, thank you so much. I appreciate the time. Hello, Shashi.
Yes.
Yeah. Do we have any questions on the chat?
Yeah, we have two questions. The first one, so how do you differentiate test failures when you have false positives or due to real defects? How do we handle this?
Like failures due to false positives.
Yes, correct.
Right. So that's a very good question. So there's two approaches that we use for false positives, right? The thing to understand about false positives is that the false positives are normally caused due to non-determinism, right? And we have to understand what the source of the non-determinism is. So the two approaches, normally, like if you have something like a timestamp that is part of the response, right? Then just by virtue of the fact that the observation happened at time t0, and then the replay happened at time t1, you know that basically makes it impossible for the two scenarios to agree on the time, right? Because the time was different and the clocks are also different. So the thing that we do there is we automatically detect these fields by running the same simulation multiple times, because what will happen is that when we rerun that simulation multiple times here, that same field will not be able to agree with itself on the same version of the code, right? So when there are certain fields in the schema that are appearing to be noisy, like they're basically time variant, right? And the fields that are time invariant, right, that are always the same given the same input, we know that those are not noisy, right? So that's how we detect automatically what the noisy fields are and cancel them out. That's one approach that we use, right? A better approach that we use in conjunction with this one is that we our instrumentation not only captures the behavior of all these downstream services, but it also captures the behavior of any non-determinism source of non-determinism that you might have inside your code. So things like timestamp generators would be observed by our SDK, and what that would allow us to do is replay the time when we are replaying that scenario, right? So imagine, like this is actually a real example that we had with a customer where, they had some logic to check whether a coupon code is expired or not, right? And that is an extremely time-sensitive piece of code, right? So if you have a coupon that code that you checked in production, let's say at 1 second before it was about to expire, right? Then the coupon was not expired, and the behavior that you saw here was that this request for this coupon came in, and the response was this coupon is valid, right? But by the time you get that sample to your test environment, right, uh, the coupon has now expired. So you do the same request, and now this time the response comes back that the coupon is expired. That's not your code's fault, right? It is basically the fact that the time has changed, right? So by having our SDK watch the time, what we did there was like we were able to replay the time. And so this is like very cool time travel stuff right there. So you can basically then, pretend as if the time was exactly the same as when the sample was collected. And then, the response comes back that this coupon is not expired because the time at which the simulation is being run is the same as the time at which the sample was captured. Same thing applies to random number generators or any other sources of non-determinism. All we have to do is make sure that the SDK is watching those sources of non-determinism, and once you've instrumented all the sources of non-determinism, then your service becomes completely deterministic, and so then you don't have to do any kind of noise cancellation, right? So noise cancellation, the first step that I described earlier, that's a fallback that we have, right? But our goal is to basically eliminate all noise altogether by making the code completely deterministic. Given the same input, it always produces the same output. So that's an answer to the first question. I hope that that answers the question. What was the second question, Shashi?
Yeah. The second question is from Srinivas. So Srinivas is asking, will technology matter here, or isotope is independent of technology used?
So technology marker, can I get some more elaboration on that from Srinivas? What he means by technology marker?
Srinivas, you can have the chat on the thread, or I assume, yeah, so basically irrespective of Java or C++, not the services.
I see. Yeah. So, currently with Isotope, right, we offer, SDK support for Java and Node.js. But the idea is fairly generic, right? And we're in the process of writing additional SDKs for other languages also. Eventually, we hope that the community can help us write these SDKs and maintain them. But for now, we're trying to make sure that rather than upset too many customers at the same time with quality concerns, if we can just make a small number of customers happy with by restricting ourselves to a smaller set of languages, then that would be a good place to start. So right now we only have support for Node.js and Java, and we are happy to work with anyone here who has those requirements. If you've got like Java, and most people who are using Java are also using Java Spring Boot. At least that's what we've seen across our customers. So we have fairly a large customer base that's using those two SDKs right now. Any
Cool.
other questions?
Yes, we have two more questions, and the third question is from Omkar. Is it something similar to tracking events in Mixpanel?
Tracking events in Mixpanel. So so first off, I have to provide a disclaimer. I have a lot of friends at Mixpanel. If they're watching this, I am about to be exposed. So they might not be very happy with me. So I don't know specifically about the events feature in Mixpanel, but I know that Mixpanel, for example, also uses Diffie. Right? They in fact wrote a blog post about us, and Diffie is sort of the open source predecessor to Isotope, right? The scope of what Mixpanel does with any kind of tracking is ultimately to provide its users feedback on metrics, whereas the scope of where we are coming from is more about simulation, right? Where you are replaying scenarios, right? So I think that entire scope of replay lies outside of mixed panels purview. I have to caveat that with, like, I don't really know exactly what the mixed panel events feature does. So my apologies for not being able to provide a better answer there. And I hope my friend Chinmay, who's the VP of engineering there, is going to forgive me for being so ignorant about his product, which he has put his heart and soul into. So sorry, Chinmay.
Okay. We can move to the next question. Lavanya is asking, if there are sensitive network calls like payments, is there something that can be done to ensure that unexpected side effects do not occur when we replay it on our test environments?
Right. So that's a great question, Lavanya, and I want to answer it in two parts. The first part is, unexpected behavior in test environments is a very good concern to have, right? So side effects would happen when you have like these downstream dependency connections, right? Like this MongoDB, this MySQL, anywhere where you could actually mutate the data, right? But what is happening with isotope is that there is no downstream dependency that gets deployed, right? And this is very hard to accept because we are so used to, setting up, like it takes a huge amount of effort to set up these test environments and then tear them down and then set them up again with the right data and then tear them down, right? And what we are claiming here is that none of that is required, right? That you actually don't need an environment at all. And the reason why you don't need an environment, let alone your production environment or any other environment, is that all of these behaviors, right, at the request level are being captured and being automatically mocked within the code itself. So the SDK itself is mocking the behavior of all of these downstream stateful dependencies without making any network calls to those real deployments, right? So that is the first part of the answer, right? Now, the second part of the answer is that, security is a very important thing. You talked about, like, sensitive data fields and payments and things like that. And we take that very, very seriously, right? Our customers force us to, when you're working with, people like banks and people who are running like, trading shops, there's very sensitive data that is flowing through their systems. And what we do is we provide with the, some very cool sanitization logic. So when a sample gets collected in production, right, before that sample ever leaves the host, there are custom sanitization rules that are applied to every sample before it gets emitted to the isotope backend. And these rules are completely up to the team that owns the service, right? Like they can basically say that this particular field contains PII data, so I want to apply a one-way salted hash to this field. I want to encrypt it, right? I want to replace this field with some other value, right? And then with that obfuscation and redaction and all of that flexibility that you have on the rule engine side, right? You are able to make sure that the sanitized sample is what you ever have available during simulation. So now, even if your engineers have access to these samples, the samples have already been sanitized and they don't contain any sort of sensitive information that you don't want to expose your own quality engineers or developers to, right? So that makes this value proposition more safe and significantly de-risks that concern. Thank you for the question.
Nice. We have the final question here from Andreas. Can you show us an example of a test run, successful and simulated failing?
Sure. Let's see. I just did that. So we've got this geo service here, right? So we have this one has a failure in it, and then these previous ones all passed, right? So when it passes, it's all green here, right? And that's it's not very interesting when it's all passing, but like you can go look at what these values are. It gives you a good way to discover your own schema. if let's say like a new developer comes on the team, or new quality engineer comes on the team, they want to understand like what are the downstream dependencies this service has. So they can go look here that, okay, these are all the downstream calls that my service is making. They can also look at like, okay, if I want to send a request to this service, this is what the structure of the request should be. These are some sample values that I can use, and so forth. This is an example of a test run that has passed with 1236 samples. And then if I go back my simulations and then go to GeoService again, look for a failure. This is the one that has failed, right? So it has failed because one of the endpoints failed here. And so that's where we went and looked at what was the structure of the request body with hub IDs and association type. And then the response body had latitude and longitude in it. And then it also had these downstream calls, which we successfully recorded and dynamically mocked. So those are examples of successful run versus failed run. Right? Cool. Well, Sashi, I think you said that was the final question. So thank you so much for the opportunity to interact with a wonderful community. It was my pleasure to talk to all of you. Thank you so much.
Thank you, Puneet, for your time, and thank you all our attendees. Thanks for your time too. I hope you have received another perspective about the service backend service testing. And here we are going to announce our next meetup on in this month itself on October 29th. Lemoy will be talking about integrating end-to-end test into CA pipeline. So I have already pinged the sign up link on the chat, and we will be sharing this again on our social media platforms. So please do sign up and stay tuned. Thank you. Bye-bye. Happy weekend to everyone.
Thanks, guys. Bye-bye.